Thanks for your attention, and we're now ready to start this afternoon's presentation. And I'd like to introduce Jeff Bigos to you, who will be your presenter today. Jeff?
Thanks, Catherine. Good morning, or good afternoon. My name is Jeff Bigos, and I'm an instructor here in the Educational Services team here in Redlands. Joining me today is Catherine Jones, who is a product specialist for ModelBuilder in the software products team here in Redlands. Thank you for joining us, Catherine. I want to welcome you all to today's live training seminar. In today's seminar, we are going to cover some of the basics of geoprocessing with ModelBuilder. In this seminar, we will cover creating models of our GIS workflow, editing model elements and repairing broken models, and finally, documenting and distributing our models. After each topic, we'll have a demo, followed by a review and a question and answer session. First off, we're going to touch upon the basics of geoprocessing and creating models. In topic 1, we're going to cover the following issues: geoprocessing basics, what is a model, why build models, model elements, creating a model, model states, and finally, running a model. To get started, we have to look at what geoprocessing is and how it applies to model building. Defined, geoprocessing is a GIS operation used to manipulate data stored in a GIS workspace. Geoprocessing is one of the most important aspects of a GIS because it provides us with the tools necessary to perform data analysis, conversion, and management. At its core, geoprocessing is as simple as converting data from shapefiles to geodatabase feature classes, or performing buffer analysis on our input data. Many ArcGIS desktop extensions have a toolbox associated with them, such as Spatial Analyst, Network Analyst, Military Analyst, and finally, the data interoperability tools. Geoprocessing tools work with all ArcGIS supported data formats. They are also available in ArcMap, ArcCatalog, ArcScene, and ArcGlobe. There are 4 different ways to interact with the geoprocessing framework, all of which are initially taken from Arc Toolbox. They can be accessed and run through their tool dialogs from Arc Toolbox, interactively typed in the command line window, used in a geoprocessing script environment like Python, and finally, we can work with the tools in ModelBuilder to build GIS task-based workflows. So let's investigate using models with geoprocessing. In ArcGIS, a model is displayed as a model diagram, like what you see here. You can automate your workflow by stringing data and tools together in the model diagram that will run in sequence. So why would I want to build a model? Building a model helps you to manage and automate your geoprocessing workflow. It can help with simple multi-step tasks, such as adding new fields to a feature class and then calculating values for those fields. Models are custom tools that you create. They can be run multiple times, and you can apply different data sets each time you run it. It gives users of your models a clear and concise representation of the geoprocessing work that will take place. Here's the ModelBuilder interactive window. This is the window where your model building is going to occur. When open, you will drag and drop in geoprocessing tools and project data and connect them into processes, which are then connected to create a workflow. So let's take a look at the different kind of elements you'll use when building your model. First off, you'll be working with project data. Project data is your input data that exists before the model runs. Most of you work with this data on a day-to-day basis. This is the input data to your model, the data that will go through the model and generate your result. Tools represent the geoprocessing operation that will be performed on the project or input data. This might be a buffer, a clip, or a union tool. Now, tools fall into 2 categories, system and custom. System tools are provided to you by ESRI through our toolbox. Custom tools are models created by you in ModelBuilder, script tools built with Python or another scripting language, or tools you've written using ArcObjects code. Derived data is the result of tools run in the model. It is the data that is generated as the outcome of a tool in your model process. This generated result can also be used as input into another tool in the model chain. It will also be the end result of your model. ModelBuilder provides that kind of functionality to chain tools and results together. At its simplest, the line connector is a line that shows a sequence of processing. However, it's much more than that. The line connector will allow you to connect your project or input data into a geoprocessing tool. Using this element will populate some of the necessary input parameters to the tool. Each of these elements together create a process within our model, and a model is composed of one or more processes. To begin, you have to create a model. To do that, you need only right-click on a custom toolbox, then select New Model. This will bring up the ModelBuilder interactive window that we talked about earlier. Now, before we apply our new knowledge and create and run a model, we need to look at model states and running a model. As you create and edit models, you'll begin to notice a change in the color model elements. These colors give us an indication of the state of a model. When you open a model, you will see one of three different states: not ready to run, and has been run. For not ready to run, in this case, there may be parameters not set. Reference data no longer exists or has been moved, or perhaps a parameter value is invalid. For ready to run, all parameters are valid and executing the process should be successful. For has been run, a shadow box around elements tells us that they've already been run successfully. Now that we've looked at the basic building blocks and how to create a model, let's run one. Once you're ready to execute your model, you can run a single process of a model like the Select or a Clip tool. We can run all processes that have not yet been run. And finally, we can run the entire model, including rerunning any previously run processes. Keep in mind that the more processes being run, the longer the processing time. Hence the reason you're able to run just ready-to-run processes. When each tool is run, there are status messages generated. Status messages will include parameter values, the start and end time of execution, status of execution, and any error messages that are generated by the tools. We'll look at these again in topic 3 when we look at model reports. For now, let's take a look at a demonstration on how we're going to go about creating a model. Now to start, we're here in ArcMap, and I've got a custom toolbox loaded in Arc Toolbox called model_LTS. Inside of model_LTS, I've got some system tools, a Python script, and some models. Now to start, I have to right-click on my custom toolbox, go to New, Model. Now that brings up the ModelBuilder interactive window. Okay. Now for our analysis, we want to create a model that'll help us determine the total surface area of water for a selected country. Now I've got two layers loaded in my ArcMap TOC. I've got one that represents countries of the world, and I've also got another one called World Lakes, which represents some of the major and minor lakes around the world. So first off, what I want to do is take this country layer and drag and drop it into my model. And this is going to serve as the input data or the start point for my model. Okay, now what I want to do is the first tool I want to use in my analysis is the Select tool. The Select tool is in the Analysis Tools toolbox under the Extract toolset. So here's the Select tool. To use it, I'm just going to drag and drop it into my model, and there it is. Now what I need to do is notice it's in a not ready to run state, so I need to supply some parameters to it. To do that, I'm going to use the Line Connector tool, click on Countries, and then click on the Select tool. So now my Countries layer is an input parameter to the Select tool. Now I need to supply some additional parameters to the Select tool for it to run for me. For me to generate surface waters for a country like Iceland, I have to supply an expression. So I'm going to build one here in my query builder. I'm going to set out my country name equal to Iceland. Okay, and go ahead and click OK to each of these dialogues. Now the Select tool is ready for me to run. The next tool I want to use in my analysis is the Clip tool. So I'm going to go ahead and drag and drop that into the ModelBuilder interactive window. Now instead of using the line connector, I'm going to supply the parameters a different way. I'm going to go ahead and double click on the Clip tool and supply the parameters through these dialogues here. So for my input features, I'm going to click on World Lakes. Now this World Lakes is coming from my ArcMap table of contents. So go ahead and click on World Lakes. Now for the clip features, I want to use the output of the Select tool, and that's noted here, world_country92 select. That's the output to the Select tool. Okay. Now I've got my parameters supplied for the Clip tool. Now one thing I want you to take note of is notice the Clip tool. It's white, it's not ready to run, there's no line connectors, and we haven't added the World Lakes feature class into our model yet. So now when I click OK, all that has been added. The appropriate parameters are connected, and the World Lakes have been added into my model. Let me go ahead and resize that so we can start to see our model more. The last tool I want to use in my analysis is the Summary Statistics tool. It's available here in the Statistics toolset. It's called Summary Statistics. So let's go ahead and drag and drop that in. Let's resize our model, move this over a bit. And I'm just going to use the Line Connector tool to provide that, the World Lakes clip as a parameter to Summary Statistics. So now I also need to supply some additional parameters to the Summary Statistics tool. So I'm going to go ahead and double click and open that up. In my World Lakes feature class, I've got a square kilometer attribute. Now what I want to do is I've clipped my lakes to Iceland. Now I want to sum up the square kilometer field to tell me how many square kilometers of surface area water there is available in Iceland. So for a statistic type, select Sum. Okay, now my model is ready to run. My input data is here. My tools are on my model, and they're in a ready to run state. Now one more thing I want to point out to you is as I run this model, as each of these tools are executing, the Select, the Clip, and the Summary Statistics tool, they're going to turn red, indicating that they're currently processing the data. Okay. To run this model, I'm going to go ahead and click the play button. Okay, there goes the Clip tool, Summary Statistics. Any messages that the tools generate are being written to this model progress dialog. Okay, so we saw that the model ran through pretty quickly. We saw that the clip only took about a second, and statistics ran through pretty quickly as well. So 3 of 3 processes were executed, and our model's complete. So let's go ahead and click Close. Now the neat thing is we've generated a result. The Summary Statistics generates a table. Okay, inside of the ModelBuilder interactive window, if I want to see that table, I can just right-click on the result element here and click Add to Display. Now, if I look up the Source tab, let me move the model out of the way. I have to click on the Source tab to be able to see tables in ArcMap. So here's the result of the Summary Statistics tool, which is this table. It tells me that there's over 1,600 square kilometers of surface area waters available in Iceland. Okay, so let me go ahead and save and close this model, as we'll need it for the second demonstration. Okay, so in this demonstration, we looked at how to create and run a model, looked at the different model states and elements. So to review, in topic 1, we covered geoprocessing basics, what is a model, why build models, model terminology, creating a model, model states, and finally, running a model. And now let's turn it over to Catherine for some of your questions.
Thanks, Jeff. The first question that we'll look at here is from Neil in Albuquerque, and he asks, can AMLs be imported into ModelBuilder? Well, Neil, you can actually create a custom script tool that references your AML. And then because a script tool is just like any other tool, you can drag and drop that into ModelBuilder and chain it together to the other processes that you have there as well. So, yes. Our second question comes from Emma in Wellington, and she asks, can you use ModelBuilder to iterate through a set of individual features, performing processing on each one? So she's asking if we can do batch processing in ModelBuilder. And the answer again is yes. What you will need to do is to create a script tool, again, a custom script tool, and then you can include that into your model, and then that will do the batch processing for you in that way. And in fact, there is a technical article about that on the knowledge base that will tell you exactly how to go about doing that. And let me see, there is also a question here from Brandon in Chicago, and he says, how can we schedule to run a model at midnight, that kind of thing? Well, you can do that. That's no problem. You can schedule your task to run at a different time. What you need to do is tap into the Windows Schedule Tasks, and there is actually, again, a knowledge base doc about how to do that for you. And the actual knowledge base doc number is 27553. And we have another question here that says, from Charlie in Dallas, that says, can models be shared with other GIS users? And again, the answer is yes. Your custom models or script tools are saved inside of your custom toolboxes, and those toolboxes are saved on your system as TBX files. And those are quite small binary files that you can very easily attach to an email. And I think we'll pass it back to Jeff now.
All right, thanks, Catherine. Okay, so in topic 2, we're going to cover editing our models. Your organization is dynamic. Data comes in, data goes out. Databases and their paths change daily or weekly, but your geoprocessing tasks may not. Perhaps we want to apply one model to multiple data sets or databases. Our data might have moved from the C to the D drive. We want our models to accommodate a dynamic work environment. So in topic 2, we're going to cover some of the basics of model editing, ways to validate and repair models, and finally, ways to make our models more dynamic with parameters and variables. A model is not static, so oftentimes we have to take a pre-existing model and add or remove data or additional tools to it, or perhaps change parameter values. Or perhaps we may need to generate a different analysis or gather additional information about our data. To do any of these things, we'll have to edit the model. To do so, right-click on the model in the Arc Toolbox window and choose Edit. This will bring up the ModelBuilder interactive window. With the ModelBuilder interactive window open, we can begin to add additional tools and data to our model. Perhaps in our analysis of determining how much surface area of water there is in Iceland, we want to determine the number of water features in Iceland. With our model already created, we can drag in the Get Count tool from the Data Management toolbox. This tool will help us determine the answer to that question. In addition, we might have written and imported a Python script that helps determine additional characteristics of the water bodies that we need in our analysis. You can incorporate system tools, script tools, or other model tools into your model. Perhaps we want to apply the same surface area analysis to another country like Poland. How can we make our model accommodate this kind of change? To accommodate using another country for the same surface area analysis, we are going to expose some model parameters. In geoprocessing, a parameter is a required or optional value supplied to a tool in order for the tool to run. For instance, the buffer tool requires a distance to generate buffers. For our analysis, we need to be able to select any country to generate information about the surface waters. Exposing a model parameter allows us to accomplish this task because it allows for user input. All exposed model parameters will appear on the Model Tool dialog. Creating a parameter as a variable creates a list of all the tool's parameters. This is a great way to create an empty parameter that you could expose on a dialog, which would allow you to enter the value at a later date or allow for user input. Creating a parameter variable also allows you to use the same value for different tools. For example, if your model included more than one buffer tool, you could create a variable out of the buffer distance and connect it to both buffer processes. It's as easy as right-clicking on a tool inside our model and making a variable from a parameter. We'll look at this in more depth in the upcoming demo. At this point, we've added additional tools and set up parameters for our model. Since we're still editing our model, we need to take into consideration intermediate data. Intermediate data is temporary data that is created by tools within your model. In our analysis of surface waters, the first tool to run is the Select tool. The output of that tool is used to clip our water features. That's the extent to which we're going to use the result from the Select tool. It's not the final result of our model, but it's just data needed to continue the analysis. A few points to think about with intermediate data. Models run from a dialog box or the command line delete intermediate data automatically. Models run from within ModelBuilder window maintain intermediate data on disk. So one thing to remember is that your end result will be flagged as intermediate. So to maintain your result, you might want to check off intermediate from your end result data so that your result then gets written. In topic 1, we mentioned the 3 different states of a model: not ready to run, and has been run. The state of a model when you first open it will reflect its status when you last ran it. Anytime you open a model, it is good practice to validate the entire model. This validation will verify all parameter values to make sure they are correct. For example, whether input data is in the same location or maybe it's been moved, whether custom tools are still available or valid. To validate your model, in the ModelBuilder interactive window, select Model, Validate Entire Model. We'll look at this further in the next demo. Like most environments, the work environment is very fluid. At times, we might move our data to different network drives, or tools might get moved from project folder to project folder. Actions like this might change elements within our models. When this happens, your model might need to be repaired. If a change that affects the model occurs, then our toolbox will change the icon of your model to reflect this. When you see a red X through your model icon, you know you need to repair something in your model. Also, when you validate your model and elements return to a not ready to run state, you need to repair your model. When we edit the model, it might look like this graphic here. Notice that the country's oval is white, so it's not ready to run. It's lost its reference. Also, the Summary Statistics tool. There's a red X through the hammer icon there. That means that the Summary Statistics tool has lost a reference to the tool. Okay, so let's take a look at a demo on how to edit and repair a model. Okay, first off, I want to look at the model that we created in the first demonstration. Now what I want to show to you is the model dialog. If I double click on the model from the first demo, I see this text here that says this tool has no parameters. So if I were to click OK here, my model would run and it would return the same analysis for the country of Iceland. Now what I want to do is I want to expose a model parameter to allow people to specify their own country. So let's take a look at how we do that. To do that, first we need to edit our model. So right click on the model and select Edit. Now what I need to do is I need to expose a model parameter. I need to give people the ability to select a country that they want to perform an analysis on, perhaps Poland. To do that, in this case, I need to expose a parameter of the Select tool. To do that, just right click on the Select tool, go to Make Variable, from Parameter, and select Expression. Notice now I get a new element here. It's this one named Expression. If I double click on it, it's just the same tool that allows me to build a SQL expression. Okay. So I'm going to go ahead and close those out. Now to make this a model parameter, I have to right click on this new element and select Model Parameter. Now if I take a closer look at this, after selecting it as a model parameter, you'll notice this P. This indicates that this element is a parameter of the model. So let's take a look at what that's done to our model dialog. I'm going to go ahead and save the model, close it out. Now let's double click on the model in our custom toolbox to look at the dialog. Notice that that same expression that we just looked at is now available here. So if I wanted to reset the analysis for Poland, I could just go ahead and type in Poland. Click OK, and the model would run and generate my surface area result for the country of Poland. I need to add some additional tools to the model, so I'm not going to run it from there. We're actually going to run it from the ModelBuilder interactive window. So let's go back in and edit our model. Now before we add a few more tools, let's go ahead and validate our model to make sure that our data references and tool references have been maintained. So go to Model and validate entire model. The states haven't changed, so if I wanted to, I could rerun this analysis. But what I want to do is I want to, one, generate my summary statistics, but I also want to find out how many water features I had in this analysis. So I think a while back somebody told me about a get count tool, and I only know about it, but I don't know what toolbox it's located in. So what I could do is I could click on the search tab here, type in count, and what we have here is some results. So what the search tab did is it went through our toolbox looking for every reference of count, and it found it in these three tools here. Well, the first result just happens to be that get count tool, which is in the data management toolbox. The neat thing about the search tab is not only did it tell me what toolbox to find it in, but if I click on the get count tool, I can go ahead and drag and drop this into my model. Okay, now I need to supply the parameters to it, so I'm going to use my line connector to go from my clipped lakes into the get count tool. So now that's ready to run. Now the last thing I need to do to reset my analysis to Poland, I need to reopen this expression element, and let's go ahead and type in Poland. Okay, So all my parameters are set, my model's ready to run. Let's go ahead and regenerate the analysis. Okay, so our model ran through successfully. 4 of 4 processes were executed. Right here on the model progress dialog, notice it said row count equal to 17. This is the output of the get count tool. It tells me that there are 17 features that I clipped for the country of Poland. Okay, let's take a look. I'm just going to go ahead and save our model as we'll need it for the third demonstration and close it down. In the ArcMap TOC, I have the summary statistics result here. So if I right click and open this up, we can see here that there's over 3,000 square kilometers of surface area water available in Poland. So that's editing our model. Let's take a look at how we would go about repairing a model. So in my custom toolbox, model_LTS, I've got this model here that has a red X icon through it. That indicates to me that there's something broken inside of the model. So let's take a look and see what it is. If I right click and edit, I just need to resize the model here so that we could all see it. Let me do that. Okay. And now we've got it in full view. Okay. So the input data, country and lakes, has lost its reference, and also the summary statistics tool. So let's go ahead and repair these. To repair the country layer, I've already got my countries loaded in ArcMap along with my lakes. So if I want to repair country, I just go ahead and double click on country, use this pull down here, and I'm going to set it to the world country layer that I have loaded in ArcMap. And go ahead and click OK. Let's do the same for lakes. We'll set this to world lakes. Now our select and our clip tool is in a ready to run state. Now let's take a look at the summary statistics tool. Now I might have had this tool in a custom toolbox that probably got deleted, or the summary statistics tool got deleted from my custom toolbox. So let's go ahead and repair that. To do that, just go ahead and double click on that summary statistics. Now in a custom toolbox, my model_LTS, I already put in my summary statistics tool. So that's where I'm going to point the reference to. Go ahead and click add. Now I've successfully repaired my model. So now I could regenerate the analysis of surface waters for a given country. So in this demonstration, we looked at how to edit and repair an existing model. Now we have a question for you. Locate the review question link in the upper left corner of your browser window. Click this link now. Okay, the question is, which type of data element in a model is considered virtual? Project data, tool, derived data, or environment? To submit your answer, click A, B, C, or D, then click the send button. I'll leave this in view for a few seconds so you can determine the answer. To review, in this last topic, we looked at editing a model, exposing model parameters, creating model variables, working with intermediate data, validating your model, and finally, repairing a model. And now let's turn it over to Catherine for some of your questions.
Thanks, Jeff. Let's take a look at the first question that we have here, and this is from Dorothy, and she asks, can I use all data types in ModelBuilder, so coverages, grids, shapefiles, and feature classes? And can then data types be mixed, or do I need to convert to a common data type? Well, Dorothy, you can use any one of the valid ArcGIS data types as input and output for your tools. And then those tools are in ModelBuilder. So that there's the answer to your first question. It's yes. The second part, and that you can, I think I also answered that, yes, you can mix them around. One of your tools, the input could be a shapefile. The next tool, the next process, one of the inputs could be a geodatabase feature class, and so on. So let's see, the next question that we have then is from Ricardo, and he's saying, is there a limit on the number of processes and elements that you can have in a model? And the only limitation, Ricardo, is your imagination. So whatever you need to put into your model diagram, you can have in there. Keeping in mind, though, and I'll make the suggestion to you that I've made to other people, is that just like you would do if you were creating a file structure in Windows Explorer on your computer, you would have a sort of a plan in mind where you would have things broken down into folders and then subfolders and so on. I would recommend that you do a similar sort of thing with your models as well. Break them down into workable units. It'll make your life a lot easier when it comes to trying to make changes, or if you need to do any kind of editing, or if you need to fix things in that. And then you've got each one of those smaller models being called in another model. So sort of break it down there into workable units. Our next question it's from Terry, and he says, can you demonstrate how to create a custom script tool that runs in AML? Well, due to time constraints, Terry, we can't demonstrate that for you, but I won't leave you empty-handed. I'm going to tell you this. Go to the desktop help system, open that up, and there's a book under there called Writing Geoprocessing Scripts. There is another book underneath that called Messaging and Script Tools, which contains a page called Using AMLs with Script Tools. This will explain everything to you and actually give you a step-by-step process on how to get it done. So plenty of information there for you for that. And then we have a user in West Lafayette that says, can I use ModelBuilder and a script together in tandem? And I want to make it very clear to everybody, because this is something that sort of newer people have trouble with, that there is no difference between a system tool that we provide you or a custom tool such as a model and a script that you use. So yes, they can be used together. You can drag and drop script tools into your ModelBuilder interactive window and use those to build your workflow, no problem. And then inside of your script, you can also call a model tool, just like you would call one of our system tools. No difference there. So there's the answer to that question as well. And I think we'll pass it back to Jeff now.
Okay, thanks, Catherine. So let's take a look at the answer to the review question. So the question was, which type of data element in a model is considered virtual? And the answer is C, derived data. Okay, it looks like about 60% of you got that right. Now the answer, or the reason why it's derived data, is derived data has not been created until the model is run. At this point, we have a working knowledge of how to create and edit a model. We now want to take advantage of the portability of our geoprocessing tools. Before we think about distributing our tools, we must first document our model. This way, our users have some descriptive information about the process they're going to run. To do that, we'll consider the following: labeling, how we can document processes within the ModelBuilder interactive environment, use the documentation editor to create help for our model, see how we can use model reports, we'll briefly touch on model properties, and finally, things to consider before distributing our work. Labels are a quick and easy way to provide useful information to your user. You might use labels to briefly describe a geoprocessing tool or some input data, perhaps describe a process or provide a title to your model. There are two different kinds of labels that you can use in ModelBuilder: standalone labels and element labels. Standalone labels are not connected to process elements. They might provide an overview of the model. Element labels are labels that are connected to a geoprocessing tool, data element, or line connector. These labels will stay with their associated element if they are moved in the model interactive window. as well as being deleted if the element is deleted. As you go through and construct the model, you're going to want to provide help to the users about the model you created. There are several ways to accomplish this. As you go through and build your model, you can write help about the tools that you have incorporated into your model. Creating documentation about a process is accomplished while editing the model. Just right-click on a tool and select Edit Documentation. This will launch the Process Documentation Editor, where you can provide information about the tool within your process. Perhaps the kind of parameter values the tool is expecting, or what the process will generate. The information that you provide about individual tools gets integrated into the model help file. Documentation and metadata can be created for all geoprocessing tools that you create. This help is created by using the documentation editor accessible in our toolbox through the model's context menu. The documentation editor is easy to use and gives you lots of functionality for documenting your models. With the editor, you can provide summary of the model's processing capabilities, examples of how to use the models through either command line or scripting, describe the different parameters required to run the model, and perhaps some usage tips. Provided that documentation has been created for your model, you'll be able to access it 3 different ways. You'll see a model help page. In our catalog, you'll be able to look at, from the metadata tab, metadata associated with your model, and finally, the model's dialog side panel. Here's an example of the kind of output you could expect when looking at help from the model from our toolbox. The output created from the model is a professional-looking HTML help file that has been integrated within your tool. The help page will open in your default browser and will show you information such as a description of the model, some usage tips that will help you run the model successfully, syntax necessary to execute the model in a different geoprocessing environment like a command line or a script, some examples and details about each process in your model. You can access this help page by right-clicking on the model in our toolbox and selecting Help from the context menu. In our toolbox, you can click on the Metadata tab to return simple metadata about your model, such as a brief description of the tool, who designed it, and perhaps how to contact them. It should also include keywords that will allow you to utilize the search capabilities of the application, kind of like what we saw in the second demonstration. Finally, you can create help that will appear on the Model Tools dialog side panel. A brief description of the tool and its parameters will appear. Plus, by clicking the Help button on the dialog, you can open the full help page. A model report is a good way to track properties of your model. The report will provide information about the last time it ran. It will tell you what data sets were used in the model, the different tools used, model variables, status messages for each process, and also processing times. So let's move from documenting your model to learning how to distribute your model. To do that, we'll look at setting model properties and storage options, and finally, things you need to remember before distributing your models. The Model Properties dialog allows you to set a name and a label for your model, write a description for your tool, and perhaps set a custom style sheet for the dialog. Included on the General tab is an option that pertains to distributing our geoprocessing work. On the Model Properties dialog, we have the ability to set relative paths, meaning path names will be maintained relative to the toolbox or workspace that contains the model. Now there are two different storage options for your toolboxes. They may be stored as standalone TBX files or stored inside of a geodatabase. Standalone TBX files are shareable. For example, they can easily be attached to an email. This type of toolbox is located in your Documents and Settings folder by default, but you can change the save location through the Options dialog found in the application. Automating your own workflows and automating other people's workflows is ultimately the point of ModelBuilder. Automating your own workflows is simple. You know where your data is located, and if it moves, where your toolbox is located. Automating workflows for other people is just as easy as long as you keep several things in mind. When you share toolboxes or tools with other users, you have to make sure to set the toolbox to read-write, share all data used in the tool, share any scripts or additional models used, share all documentation, share additional files such as graphics and style sheets, and finally, set relative paths to the data, so if it moves, the model won't break. So let's take a look at how we can apply documentation and set up distributing our models. So we're back in ArcMap, and we're in our custom toolbox. This model, named Model, is the model that we've created in the first and second demonstrations. Now the first thing I want to point out to you is Model Properties. To get there, right-click on your model and go to Properties. This brings up the Model Properties dialog box. We're going to take a look at the General tab. Now the first thing that we want to enter is a name, and a name is used to reference our model in the command line and scripting environment. Now an important thing to remember about this name is we can't have any spaces in it. So we're going to call this one square kilometer surface area. Okay, so there's no spaces there. Now in the label, what we type in here is going to be displayed in our custom toolbox. So we're going to enter in the same text. However, we're going to make use of the ability to add spaces. So surface area. Now I want a short description to pop up on our model's dialog side panel. So here's where I enter in that description. So here's a short description. This model will determine the surface area of lakes. And let me fix that typo there. Okay, so now I got a short description about my model. This model will determine the surface area of lakes. If I wanted to apply a custom style sheet, I could browse for it here. Most importantly, with the General tab and distributing our work, is this property to store relative path names. This is a property that will make all path names within our model, within our tool, relative to the toolbox location. So let's go ahead and check that off. So that's the General tab. On the Parameters tab, in the second demonstration, we exposed a parameter to the Select tool as a model parameter. And that's what we see here. So we've got the name expression, and the data type is a SQL expression. So you'll see all your model parameters here in this tab. We can also set up some environment settings, and if we had a CHM file or compiled help, then we can apply that here. So let's go ahead and click OK. Notice that the label has changed on our model from model to square kilometer surface area. Now let's take a look at what it did to our dialog side panel. So we double click on it. Now we've got a brief description about our model on the side here. This model will determine the surface area of lakes. Okay. So now what I want to do is I want to go in and document some of the processes within my model. To do that, I have to be editing the model. Now I want to briefly describe the Select tool. To do that, right-click on the Select tool and select Edit Documentation. This brings up the Select Documentation Editor. I can provide a paragraph of text, some bulleted items, provide links to other files. Perhaps I had an illustration, maybe a picture of what some of the lakes looked like. So I can provide that here. For now, I'm just going to put in a simple paragraph. So let's put in, we'll select the country provided in the expression. Okay, fix that. So now we've basically documented the Select tool. Okay, it will select the country provided in the expression. Click OK. Now let's document something about the Clip tool. Right-click on the Clip tool, select Edit Documentation. Now instead of doing a paragraph, I'm just going to add some bulleted items. So here I'm going to say, uses the country from the Select tool. Okay, so there's one bullet, and then I'm going to add another. Clips the lakes with the selected country. Okay, so we've got two bulleted items that's briefly going to describe the Clip tool within our model. So that has now been applied to the help associated with the model. So let's go ahead and save our model and close it out. Because what we're going to do is we're going to look at the documentation editor in the model. Up to now, we've just described two processes within our model. So let's take a look at what that's done for us. If I right-click and go to the help, if I click on model, here's my select and here's the Clip tool. Here's the two bits of information that I just put in. We'll select the country provided in the expression, and then here's my two bulleted items. Okay, so those are the two processes that I just documented inside of the model. Now let's go into the documentation editor. So right-click on your model and go to Edit Documentation. That brings up this documentation editor. Now there's two sections here. There's general information and there's help. General information is going to apply to the metadata of your model. So we can provide an abstract, some keywords, some author information, maybe constraints to the model. Now what I'm going to do is I'm going to provide an abstract to the model. So let me get that here. And I'm just going to paste that in. So I got to fix up my text here. Okay, so that will display properly. So this is just an abstract about what the model is going to do. Now the important thing to consider here is what I put in this abstract is going to replace the description in my model dialog side panel. So before I just entered in a very simple line of text, one sentence, when we're looking at the model properties dialog. On the general tab, I entered in a one sentence description. This abstract is going to replace that description. Okay, for keywords, I want to be able to utilize search to find my model. So I'm going to type in Iceland, and let's also type in surface area. So that if I want to locate the model, I could just type in surface area and it'll go and find my model. Okay, if I had information about the author, I could provide that here and how to contact them. And then finally, constraints for running the model. Okay, so now we're going to jump into the next section, and that's the help section. So when I right-click on my model tool in my custom toolbox and go to help, this is where I enter in that information. Okay, so for a summary, I'm going to provide a paragraph, and I'm going to make it the same text as the abstract. Again, let me just fix this up. Okay, so my summary is ready to go. I could provide an illustration, maybe some usage tips on how to run it. Command example, if I wanted to provide additional information to people about how to run this model from the command line, here's where I'd type it in. Same with the script example. If they wanted to run my model from a geoprocessing script, like Python, we can enter in additional information here. What I want to do though is I want to enter in some information about parameters. Now notice here, we exposed a parameter in the second demonstration, the expression. Here I've got two things that I could document, command reference and dialog reference. Command reference applies to the model help. So I'm going to go ahead and just type in a quick sentence. So use a SQL expression to select a country. So I'm going to use the same text here on the dialog reference. Now the command reference shows up on the help. The dialog reference will show up on the model tool dialog. I'll show you what I mean by that in just a second. So go ahead and click on the paragraph. Let's just paste in that same text. Okay, now I'm going to click Finish. So if I right click on my model and go to Help, if I go to Scripting Syntax, notice here the expression, what I entered in for the command portion shows up here. Use the SQL expression to select a country. Here's the summary of my model here. And then of course the processes that I documented before. Now if I double click and open up my model, here's my summary, or the abstract in this case. Now if I click on the expression parameter, notice that the text has changed to use a SQL expression to select a country. So in this demonstration, I showed you how to document individual processes within your model and also how to use a documentation editor to document your model. To review, in the last topic, we looked at labeling, documenting model processes, the documentation editor, model reports, model properties, and finally distributing models. And now it's turned over to Catherine for some more of your questions.
Thanks, Jeff. I think we have a couple of minutes to answer just a few brief questions. We have a user here from Kalamazoo that wants to know the knowledge base article number for batching models, and the number you're looking for is 26892. And there's also a help page titled About Batch Processing with Geoprocessing Scripts. If you go to the desktop help system and search for that, you'll find that as well. We have another user in Champaign that says, do all tools in a model share the same model environments, and can each tool have its own environment settings? It's a great question, and environment settings throw off a lot of people. There's a hierarchy to environment settings. The lowest level is if you set it in the application or if you set it in the ARC Toolbox window, those environments will apply to all of your custom tools and all of the system tools as well, so every tool. If you open up the ModelBuilder interactive window and you set environments inside the window, that will apply to all of the tools and or processes within just that one model. But you can also, and that will override what you've set in the application. You can also right-click on each one of the tools and set specific environments just for that tool, and that will override all of the other settings. So hopefully that'll clear it up. There are help pages that will help you with that as well. And let's see, we have another question here. It says, can you clarify the role of intermediate data? When is it temporary and when is it saved to disk? Well, intermediate data is that data that is in your model. As you step through each one of your processes, there's an input and there's an output, and that output then becomes the input to the next process. This is what we class as intermediate data. We're more than likely not interested in each one of those individual steps. What we want is the end result of our model. So those individual steps along the way, those results are classed as intermediate. All intermediate data is flagged as temporary unless it's data from an exposed model parameter or the output of the process updates the input of the process, so like an add field tool, for example, where the output is just an updated version of the input. It's saved to disk if you uncheck the intermediate option, or if you run your model from the interactive window. Then all of your intermediate data is always saved. That way it can tell you, it can maintain the model state for you the next time you look at your model. However, if you run your tool from the ARC toolbox window or at the command line, your intermediate data will be deleted at the end of execution. And just one other brief thing to a question here is from Brian and Jackson, and he says, are there any rules about which process will run first in my model? And this is something for you to keep in mind. There is no guarantee as to the order and how the processes will run. The only way you can guarantee that is if you set something called preconditions. And there's quite a bit of write-up about that within the help system to help you get through that. And let me sort of briefly explain that. If you had a process or a string of processes and it was a single string, so you had, 3 processes and they all chained one from the other, it would be acceptable for you to assume, and it wouldn't be wrong, that it would start at the project data and step through the 3 processes until it reached the end. But for the majority of us, when we build models, it's going to have more than one chain involved. And you'll find then the chains will converge and diverge as you work through your model. And in those cases, the only way to guarantee what will get run first and what will have, what has to be run before other things is to set something called preconditions. All right, and that's all the time we have for questions right now, so I'm going to pass it back to Jeff.
Okay, it looks like we're out of time. For more information about model building and geoprocessing, there's a virtual campus course called Geoprocessing with ArcGIS Desktop. For instructor-led training, there's the Advanced Analysis with ArcGIS. And finally, in product documentation, there's a book called Geoprocessing in ArcGIS. In about a week, a recording of this presentation will be on the ESRI virtual campus for free. The resources listed here and more will be available to you from that site. On behalf of ESRI, I would like to thank you all for attending.